Look at the quadratic formula now and let's understand the two preludes we used, right? So the one prelude was prelude 1. Let's just actually tell you what those preludes were. Prelude 1 was the plus minus 1, and then prelude 2 was talking about fractions. Now we want to use both properties and understand what is essentially happening over here. And this is as follows. Okay. Firstly, you need to know that this involves two equations. So the first equation I'm going to write on this side as going to be, or the first expression is minus b plus the square root of b squared minus 4 times a times c. And the second one is going to be minus b minus the square root of b squared minus 4 times a times c, all over 2a. Okay, so there we've used prelude 1 to establish that this is two equations, or two expressions, right? The second thing that we now need to look at is breaking each term. Yes, two terms on top and one term at the bottom, so it satisfies our condition of many over 1, right? Many over 1. And that means I can take each term and just break them down. So I'm going to say that's minus b all over 2a plus the root of b squared minus 4 times a times c all over 2a. And this thing over here is going to be minus b over 2a minus the root of b squared minus 4ac over 2a. Okay, so I now have a question for you. When will both of these fractions, or both of these expressions, be equal? When will this expression be equivalent to this expression on this side? When is that the case? Do you agree that in both fractions, or both expressions, minus b over 2a over there and minus b over 2a over there, they have the same value? Okay? And then in this case over here, you're going to add something. You're going to add some positive number, and in this case over here, you're going to subtract some positive number. So here you're subtracting a number, here you're adding a number. If the first part, minus b over 2a, is exactly the same, when I add, let's say you have the number 5, and let's say this minus b over 2a had the value of 5 for argument's sake, right? 5 plus something is different from 5 minus something. My question, however, to you is, when will 5 plus something be the same as 5 minus something? What must the value of something be? Very good. The value of something must be equivalent to 0. Now, if this equation, or this expression rather, this part over here, if this is a value of 0, and this is a value of 0, it's not always the case. Sometimes it's not 0. But if it had a value of 0, then minus b over 2a plus 0 is exactly the same as minus b minus 0. Minus b over 2a minus 0 is exactly the same as minus b over 2a plus 0 if that happens, if this thing turns out to be 0. And therefore we say that the roots will be equivalent, because this is the value of root 1 and this is the value of root 2, this thing over here. If the delta value is 0, 0 divided by 2 is still 0. When delta equals 0 divided by 2a, it's still 0. And 0 divided by anything will be 0. Okay? And so my key over here is to understand that when this delta value is 0, my roots will be equivalent. And the reason for that is my root will only have a value of minus b over 2a, and that is exactly the formula for the turning point. Okay. Right. When it is positive, it's going to have some value, and therefore it will have different roots. Okay, so I think that was just to get you to understand the quadratic formula using our two preludes, and then the last video that we will do in this section will be the summary of the nature of roots.